Welcome to AXIOM. Today's topic is charge. So over the next few minutes, we will try to understand what electric charge is and what are its properties. So electric charge, the definition of electric charge is that it is the intrinsic property of subatomic particles by which they experience electrostatic force. We will analyze it all together. So what is intrinsic property? Intrinsic property, that means it is the inherited property. It lies within it. Suppose to explain intrinsic, I can say that my ears are extrinsic organ, they remain outside, but liver or kidney are intrinsic organs, they remain inside. So just like that, electric charges are the intrinsic property of subatomic particles. Subatomic means inside the atom. So inside the atom what remains? Electrons, protons, neutrons. That means electric charge are the properties of them. Suppose electron has a negative charge, proton has a positive charge. So that's the definition of electric charge. If we look at electric charge from any element's point of view, let's consider sodium. So sodium is basically written as Na and its atomic number is 11. Atomic number 11 means there are 11 protons and 11 electrons. So when they are same, that is number of protons and number of electrons are same, then the sodium atom is neutral. But for table salt is sodium chloride. What happens in sodium chloride? Sodium gets rid of its one electron. So if sodium gets rid of its one electron, what will happen? The number of electrons will become 10, whereas the number of protons will remain 11. So that means now the number of protons are greater than the number of electrons. So that's how sodium acquires positive charge. How many protons are more than electrons? 1. So that means sodium will be written as Na positive. For table salt, the other element is chlorine. What happens in chlorine? So chlorine's atomic number is 17, meaning the same thing, 17 electrons are there, 17 protons are there. So when they're equal, chlorine is neutral. But the electron which is sent by the sodium to chlorine accepts it, takes it within its atom. So now what will happen? The number of electrons become 18, but the number of protons remains 17. So the number of electron is greater than the number of protons, and that's how chlorine acquires negative charge. Again the same question, how many number of electrons are more than number of protons? 1. So the charge of chlorine will be -1. So this is positive charge, this is negative charge. Simply speaking, when any object or anything loses electron, then its charge becomes positive. Just like the sodium loses one electron, its charge becomes positive. Whenever any object accepts charge, then its charge becomes negative. So if I have two bodies A and B, I rub them together, electrons are transferred from A to B. So electrons are transferred from A, that means A has a deficiency of electrons, so A's charge will be positive. Whereas if you take B accepts the electron, so it has excess electron, that's why its charge will become negative. So that's basically electric charge. To sum it up, positive charge means deficiency of electron, negative charge means excess of electron. Now, what are the various properties of electric charges? Let's analyze that. Electric charge has first property called additivity of charge. What is additivity of charge? You take any isolated body means it is not connected with exterior or surroundings. If it has charges, let's say Q1, Q2, Q3, various Qn charges, so the total sum of charge will be simply the algebraic sum of all the individual charges. Meaning, if we have a body which contains charges Q1, Q2, Q3, Q4. Some of them may be negative, some of them are positive. So the total charge of this body will be simply the sum of all the individual charges. That means Q1 plus Q2 plus Q3 plus Q4. There is a negative sign in front of Q2. That's all right. Negative positive becomes negative. So Q1 minus Q2 plus Q3 plus Q4. So this is called as additivity of charges, and that's the first property of electric charge. What is the second property of electric charge? That's called quantization of charges, which we are going to discuss now. What is quantization of charge? For that we must know what quantum means. Quantum means basically the building blocks. You consider any room. So a room, how it is built? It is built by bricks. So each individual brick, you can consider it to be a quantum. So what is quantization of charge then? Quantization of charge states that the total charge of any body is an integral multiple of a basic unit of charge, which is the charge of an electron. That means the mathematical formula for quantization of charge is Q equals to NE, where E represents the charge of an electron whose value is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the SI unit of charge, and this N, it can be plus minus 1, plus minus 2, plus minus 3 and so on. So what do we mean by integral multiple of charge of an electron? It means that if you consider any body, it can have charge equivalent to the charge of single electron, 2 electron, 3 electron, 4 electron and so on and so forth. But it cannot have a charge of half electron. It cannot have a charge of fractional value of electrons. That means it can either have 1 electron, 2 or million billion. It cannot have half electron. That's basically the quantization of charge. So for an example, let's say I am combing my hair. So in doing so, any number I am considering 10 to the power 20. 10 to the power 20 electrons are transferred from my hair to my comb. So now we will try to figure out by quantization of charge that what is the charge acquired by my comb, right? So N is 10 to the power 20. You notice it is not a fraction, and E is 1.6 into 10 to the power minus 19 coulomb. So the charge on my comb will be N into E 10 to the power 20 multiplied by 1.6 into 10 to the power minus 19. 1.6 into 10 or 16 coulomb is the charge of my comb. But the question still remains, the charge is positive charge or negative charge. We will go back to this concept. What was positive charge? It was deficiency of electron. What was negative charge? It is the excess of electron. Now the question clearly says that the electrons are transferred from my hair to the comb. So the comb now has excess of electron. That's why its charge is going to be obviously negative. So I will finally write that the charge on the comb will be minus 16 coulomb. And that's quantization of charge, which says that charge is not continuous but remains in small discrete packages, which is equivalent to the charge of a single electron. Although there is an exception, this quantization of charge is applicable for microscopic charge. That means when the charge is small. But if you consider macroscopic level, then it does not hold true, because then the charge is continuous, because the number of electrons are so high that it loses the quantization of charge property. Another property I want to discuss is conservation of charge. What is conservation of charge? It basically says that charges can neither be created nor be destroyed. it can only be transferred from one body to another. It's just like the this law of conservation of energy, which says energy can neither be created nor be destroyed. It can only be transformed from one form to another. So just like that, charges, you cannot create them, you cannot annihilate them. What you can do is you can transfer one charge from one body to another body. That's conservation of charge. If you want to know an example of quantization of if you want to know an example of conservation of charge, you can look for in nuclear reactions, where total charge before and after the reaction will remain same. Also, there is this example of annihilation of matter. Annihilation of matter means if you take a positive charge, you match with a negative charge, then it will vanish. Like if you add one electron to an positron, then you get gamma rays or annihilation of matter. What is positron? Positron is the antimatter of electron. Antimatter of electron means it has the same charge as electron, but it is positive. It is found in cosmic rays. So that's one example of conservation of charges. So to sum it up, what is charge? It is the intrinsic property of subatomic particles. It is the intrinsic property of subatomic particles by virtue of which they experience electrostatic forces. What are the properties of charges? It has the property of additivity. That means if you want to know the total net charge in any enclosed medium, you just have to add them algebraically. Q1 plus Q2 plus Q3 plus ... Qn. That's additivity of charge. Second is quantization of charge, which basically means that the total charge of any body is the integral multiple of charge of a single electron. And next comes the quantization of charge, next comes the conservation of charge, which says that charges can neither be created nor be destroyed. It can only be transferred from one body to another body. Along with it, there are other properties such as alike charges repel each other, opposite charges attract each other. We all know about that. That's why I haven't discussed it in length. So that's all about charges. I hope you got to learn few new things and clear your topics. Thanks for watching.